everyone, and thank you for joining this video by Power Wireless discussing Open RAN total cost of ownership and how it supports 5G smooth migration going forward. In this video, we are going to discuss the following topics. We are going to start with Open RAN and how it is positioned against legacy networks, advantages, disadvantages. We're also going to discuss what is driving the Open RAN today and what is causing the market to demand it. We're also going to talk a little bit about the CAPEX and OpEx costs and where each one of them is coming from. We're also going to discuss reduction of CAPEX and OpEx in order to understand how we can reduce those values and that lowering the TCO. And at the end, we are going to do a short summary to recap what we have been discussing. Start first of all by explaining a little bit about legacy networks which are deployed today worldwide and Open RAN networks that are being deployed today and will be deployed going into the future. First of all, it's important to understand that legacy networks are monolithic in nature and usually involve a single vendor which is dominating both the solution hardware and the solution software in any given moment. Virtualization, which was introduced in recent years, has not changed this basic concept. And both network topologies and individual site topologies are still based on a single vendor with proprietary interfaces dominating the solution, although the solution might be virtualized and may run on several different hardware platforms. Still, the overall solution is still being provided by a single vendor, and the interfaces are proprietary and cannot be integrated with other vendors. The current virtualized RAN solution is still being provisioned by one of the incumbent players using their certified hardware and software combination. None of the incumbent players can work within a single site with the hardware or software from any other incumbent vendor. Open RAN, on the other hand, is all about generic predefined interfaces between different building blocks that together comprise the Open RAN solution. These building blocks are known to us as the radio unit, the RU, the distribution unit, the DU, the centralized unit, the CU, and the radio interface controller, which is the RIC. The open interfaces is a very important piece of the puzzle that will, at the end of the day, enable MNOs globally to leverage competitiveness between different suppliers in order to lower costs and in order to be able to implement the best of breed solution when they design the network. Because now they will not be mandated to buy the solution from a specific vendor. And on the other hand, they will be able to buy the best available solution or the best available component that exists in the market from different solution vendors. Now that we have discussed about legacy networks and the advantages of Open RAN, let's elaborate a little bit about the virtualization, which is extremely important to understand the overall picture. In general, Open RAN is a subgroup of the virtualized RAN ecosystem because it adds an additional layer of open interfaces on top of the virtualization of hardware and software. Virtualization in general provides the ability to disaggregate between hardware and software, enabling us as customers to use different commercial off-the-shelf hardware elements with different virtualized software packages, unlike appliances that were used in the past. The Open RAN standard provides the ability to further enhance these capabilities and enables us to mix and match different vendors for different components which are part of the same ecosystem. Because remember, now all the interfaces are open due to the Open RAN Alliance definitions. The virtualization concept has enabled the market to disaggregate hardware and software, by that facilitating DU and CU splits within the ecosystem. But the Open RAN, as part of its workload, is defining standard interfaces between all the elements that we have mentioned before, such as the RU, the DU, the radio interface controller, and so on. And this enables us to go much beyond the simple disaggregation of hardware and software.
Now that we understood the advantages that we gain by deploying Open RAN versus legacy networks, let's take a look at an example that will illustrate what a real mobile network operator will gain by deploying Open RAN. In this specific example, we can see a network that has services which are being provisioned by a core and a transport network. Now we also see the different Open RAN components, such as the Open RAN RU, DU, and CU, which are part of the radio access network. And these are the elements which are defined as having open interfaces and can be mixed and matched between vendors when using Open RAN. We can see here that the baseband, which is represented here by the Open CU, is being divided into a virtualization software, which here in this example is V2, and a commercial off-the-shelf server, which is basically a generic server. We can also see that the second part of the baseband, which is the Open RAN DU, is being serviced by different elements, which are comprised also by a virtualization software, where in this example are represented by V3, V2, and V4, and other commercial off-the-shelf servers, which again are simply generic servers that are being used. All the servers, by the way, are x86 based. And lastly, we can see that the Open RAN RU, which represent the actual radio unit, we can see that there are 3 different radio units deployed on all 3 combinations. And in overall, we can see that we can mix and match between the different virtualized software that comes from vendor 2 or vendor 3 or vendor 4, and between the different radio heads that come from vendor A, vendor B, or vendor C. This flexibility and ability to interoperate between the elements is the real strength of the Open RAN movement. This is what we gain by utilizing the open interfaces and making sure that we are not bound by a specific vendor for the hardware and for the software. Let's understand together how an Open RAN solution looks like when it's provided by Parallel Wireless. First of all, it is important to understand that Parallel Wireless is fully committed to support and follow the Open RAN standards and definitions as they are being developed. Parallel Wireless is among the few ecosystem partners that provides various solution options which span across the complete end-to-end ecosystem, starting from the RU on one side all the way to the CU and connectivity to the core on the other side, and also providing the different ring functions. Parallel Wireless is providing RU options with multiple radio hardware vendors. These RUs can interconnect with PW DUs and CUs, or they can connect to other certified DUs and CUs from other vendors as long as they are part of the Open RAN ecosystem. We also provide software packages for DUs spanning across all the Gs, which means that we can provide service both for 2G and 3G and 4G and 5G, enabling the customers to gain maximum flexibility. These DUs are compatible with multiple x86 hardware vendors, which are part of the Open RAN ecosystem, and can also interconnect with other CUs or rig functions from other vendors if needed, as long as they are part of the ecosystem again. The same is applicable also for our CU and rig functions, which are also available by Parallel Wireless. It is important to understand that a customer has the possibility to build an entire greenfield solution using Parallel Wireless product, yet remain completely Open RAN compliant, and in the same time, the customer also has the ability to replace or extend in a brownfield network a specific component that they might need in order to complement their existing network and improve their existing solutions. This is the main essence of the Open RAN, and this is the highest flexibility possible for the customers. The Open RAN is all about bringing new way of thinking into the market. We have to look again at the entire life cycle from design through development and always keep in mind installation and ongoing support, which are just as important, if not more, than other aspects when deploying a network. If we look at the Open RAN advantages, since it's a completely new market approach, we should see that solutions are expected to be developed while thinking about customers and understanding that the customer must come first in order to simplify things. Operational models should be improved and simplified to enable painless multiple vendor interoperabilities. Platforms should be selected when we have in mind a clear understanding that it will be used in a diversified way, which will not necessarily be limited to its initial design. Integration phases that were usually done by each incumbent solution vendor should now be simplified to enable third-party integrators and maybe even sophisticated customers to complete independently or at least within minimal dependencies on outside resources. And last but not least, every piece of the puzzle should be built in such a way that it will fit into the bigger picture of the standard Open RAN ecosystem. Now that we understood the Open RAN, let's try and discuss a little bit about what is driving the Open RAN going forward. What is pushing this amazing new market approach forward? It seems very clear that the main reason Open RAN is needed so much is the clear and obvious move towards enhancing 4G and deploying new 5G network architecture and services. It seems that the current or legacy network design cannot scale in terms of performance and cost in the way which is needed to really support actual market demands. We can see that the market is acknowledging the fact that 19% will deploy Open RAN first of all to build their initial 5G infrastructure. These are the operators which have not widely deployed 5G yet due to obvious challenges as we described before. Another 40% acknowledges that they will use Open RAN to enhance their existing 5G infrastructures. These are operators usually which have already started to deploy 5G but could not complete the process again due to obvious challenges of costing. The last 41% acknowledges that they still do not have complete confidence in Open RAN and therefore they are reluctant to use it for their main urban markets. They understand the need and they want for their own benefit to push the whole ecosystem forward, so they will start gaining traction and experience in their greenfield or more remote areas, which until today they could not have provided sufficient coverage in the standard network architecture. We can clearly see that in all the groups the common thing is that Open RAN is an enabler. Open RAN enables them to improve or extend or enhance their current network in ways that they were not possible before. To really understand the challenge of 5G and why a new way of thinking is needed, we can look at the following market research, which tries to show how user and market demand can impact the TCO of a network. We can see here three different data growth options which were assumed, each one representing a different benchmark in network resource requirements and capabilities, and we can see in this research that each phase is at least doubling the requirements of its previous phase. In parallel, we can see how much additional investment will be needed in infrastructure to accommodate and enable this type of service ramp-up across the network. The added infrastructure is comprised of actual hardware CAPEX that needs to be added across the network and can translate to radios, antenna systems, towers, and even additional small cells to enhance service in black spots. The added infrastructure is also comprised of OpEx, such as enhanced transmission layers to backhaul this huge amount of traffic backwards into the COs, or large frequency slices and frequency bands to enhance the actual data rate capacity. Let's investigate the reason why Open RAN has such a significant impact on future network deployments when thinking about 5G and future network and service requirements. The RAN is at least 60% of any cellular network total cost of ownership when we combine CAPEX and OpEx together. Sometimes it could be even more depending on each individual network. If a new topology will not be ready or available when needed in order to enhance the deployment methods, then the following four main challenges will become very critical to the success of such a network deployment. First of all, the ability to lower CAPEX or upfront investment when building or expanding any given network is critical. It will be very difficult to quickly adjust the network to changing regulatory constraints for service and spectrum or coverage requirements. 3. It will be very difficult to introduce and quickly add new resources such as new layers of additional frequencies or adding new spectrum which will become available in the future. And lastly, all the above will directly impact each MNO ability to lower service prices and support a valid business plan. Today we already see that worldwide there is at least one common thing. Market is expecting to get much more while paying much less. This will be very difficult to achieve without a significant breakthrough in every aspect and a real change of mindset. When looking at the individual drivers for Open RAN adoption, we can see here in this slide a side-by-side comparison of how technical benefits and business benefits go hand in hand in influencing each other while deploying the Open RAN infrastructure. Open interfaces enable supply diversity and lower costs by increasing competition between different vendors. Automation effectively lowers overall OpEx and some CAPEX costs by simplifying installation and improving ongoing operational requirements and optimization needs for a deployed network. Innovation from using different vendors contributes to the ability to adjust ever-changing market requirements and having always the best-of-breed solution for your network. Quicker deployments enables us to respond more quickly to market trends and basically implement our innovation in a faster way, faster than used to be until today. Let's discuss a little bit about where CAPEX and OpEx costs are coming from. If we look at the total cost of ownership, the TCO of a network, we can see that roughly 30% of it comes from CAPEX, which means initial investment, and 70% of it comes from OpEx, which is the ongoing maintenance and operational costs of a network. To understand how Open RAN reduces the OpEx and CAPEX values, we should look at the following slide, which shows a legacy deployment versus an Open RAN deployment. We can see that in legacy deployments, we used to have multiple radio heads to support the different Gs, the different radio access network technologies, which were available in every individual site. These radios were connected to many baseband units, more than one. This obviously caused a much more complex installation and also enhanced the site rental fees for every single site. Now, when we look today at the Open RAN and what it provides us in terms of capabilities, we can understand that we don't need to deploy many radios as before, because today the radio access network technology can be software defined and can change on the fly. So one radio and one baseband unit can support all the Gs, not all at once, but they can change per need. This means that we install a lot less equipment that we used to in the past, and it also means that we don't need as much space as we did before, as same as for power and transmission. So we pay less for rental fees, we pay less for electricity. It all impacts our operational costs. Since Open RAN is relatively new, it presents a new way of looking at building networks, which also requires some validation and feedback from the market in order to evolve. We analyzed what existing operators worldwide, which are considered early adopters, were saying after engaging and implementing Open RAN solution. Each one of the operators in his own domain and unique market characteristics has chosen to refresh his network and build a new architecture using Open RAN characteristics. We can see that some of the operators benefited from open interfaces and the ability to add new vendors into their network, while some enjoyed the benefits of single RAN consolidation, which lowered the amount of equipment needed to provide their desired level of service. Usually, these operators have compared internally their current deployment needs when considering older 4G legacy implementation and noticed the obvious advantage of deploying their new network architecture using Open RAN. Some operators took advantage of lower deployment costs, while some enjoyed multi-RAT capabilities, which enabled them to renew and refresh their network while maintaining legacy services as well as adding new and up-to-date 4G, 5G services using the same equipment and infrastructure. Let's try now to zoom in into automation and understand how automation can help us reduce CAPEX and OpEx in order to save our TCO. We mentioned in previous slides that OpEx is 70% of a network total cost of ownership, which means that it has a significant effect on the overall potential savings of a network. Automation is one of the main drivers that affect CAPEX and OpEx spending across the different life cycle periods of a network. We can relate to 4 different segments, as we see in the following slide, where automation has a direct impact on the TCO. Building data center capabilities which support network function virtualization is the first phase of building a network and making sure that it is ready for future automated processes. Setting up a scalable virtual environment which can easily scale services from basic to advanced will be a high priority that is required in order to build on top of all other sections. Introduction of ZTP, Zero Touch Provisioning, will make sure that any automation being used will be as autonomous as possible with minimal user intervention beyond the basic definitions and rules which are required. CI/CD, continuous integration, and continuous delivery or deployment is purely targeted on ongoing operation and maintenance of a network. Successful CI, continuous integration, means that new code changes to an app are regularly being built and tested and merged to a shared repository, significantly simplifying development processes. Successful CD is all about automating additional stages of delivery and deployment. Continuous delivery means that changes to an application are automatically being bug tested and uploaded to a shared repository where they can be deployed to a live production environment by the operation team. Continuous deployment means the released software updates and versions from that shared repository can be automatically deployed to a production environment with minimal delays. Optimization is the last phase of the life cycle of a deployed network, and it purely affects the OpEx cost since it deals with remote site and network optimizations. Until today, this task was done manually by multiple teams, each team an expert in its own field. It required extensive travel and manual labor. Now that this phase will become automated, it means that not only will it be done in a fraction of the cost, but more importantly, it will be done much quicker and will enable the network to react much faster to changes while optimizing shared resources and potential savings. We try to take all the main cost reduction elements within a network and run a side-by-side comparison between them to see which has an impact on CAPEX and which has an impact on the OpEx. We can clearly see from the list that not all the cost reduction elements are affecting both the CAPEX and the OpEx. And some items, such as automation and licensing, for example, are directly affecting the OpEx but have zero effect on the CAPEX. On the other hand, we can see that some of the cost reduction elements, such as multi-band radios, have an impact on the CAPEX because it means less hardware per site, but they also have an impact on the OpEx because it means that it will consume less power and requires less physical space on a single site. Same goes for the multi-RAT DUs, which is the baseband. When we use multi-RAT DUs, it means that we can use less hardware per site because the same baseband can support different radio access technologies. And because of that, we also consume less power and we need less physical space within a site, which saves us on the rental cost. In order to try and visualize everything that we have discussed so far, we decided to try and run our own network total cost of ownership analysis. Obviously, every network has its own characteristics and unique requirements, so a specific TCO calculation should be done per network. The following example is our TCO case study of a 4G, 5G greenfield network deployment, where we demonstrate an estimated 35% cost savings between Open RAN deployment and legacy network topologies. We can see different components of the TCO calculation and how they affect the overall cost savings. we can clearly see that the more we are able to save on the remote site, which means the RU and the baseband, the CU and the DU, the bigger the impact is on CAPEX. And we can also clearly see that overall value is OpEx is much bigger than CAPEX when comparing dollar values. To summarize our TCO session, we consolidated in a single summary slide all the main aspects which make an Open RAN deployment much simpler than legacy networks. We also explained how each and every one of these elements is being addressed by parallel wireless Open RAN solution architecture. We would like to highlight the fact that Parallel Wireless, as a leading Open RAN software solution company, is committed to support and develop a complete ecosystem that will enable our customers to leverage and easily deploy or renew their networks in the most simple and cost-effective way by leveraging every advantage that Open RAN is introducing into the market.